Buongiorno baddies, welcome back to another video. Today's first question is, let x be a number between 0 and 1. Show that the square root of x is greater than x. Okay, so this problem, we can first organize our thoughts sort of by writing out like the conditions and what we're trying to prove. So just like to keep it in mind, I guess. So x is a number between 0 and 1. And we're trying to prove that the square root of x is greater than x. So there is a formula which can help us here that says basically if a is greater than b, then the square root of a will also be greater than the square root of b. So just keeping that in mind, we can write out our first condition here again. And if we square root both sides, we can have the square root of x instead of x within our conditions, which will make our working easier because now we have the term we're trying to work for here. So if we square root both sides, square root of 1. So the square root of 1 is just 1, the square root of 0 is just 0. So now we have this sort of inequality. It's an inequality. So now we have this sort of inequality. But why did we have to go that length? The reason is, if our square root of x was less than 1, then 1, that wouldn't make any sense. But 2, it would also, if you tried, because the next step, if we're trying to make it so that we can compare x and the square root of x, we're going to have to multiply all three sides of our inequality by the square root of x to create x within the same equation as the square root of x. But if the square root of x was negative, then it would flip the signs around and then that would be confusing. But we've already proved that the square root of x is not negative, so we can move on to the next step, which is multiplying all three sides of the inequality with the square root of x. So 0 times the square root of x, just writing it out. Wait, let me just create this and make it a little smaller. Boop. Okay. So is less than square root of x times square root of x, which is also x. So now we're bringing x into the same equation, which is less than 1 times the square root of x. So here you might be able to predict the next step, because if we finish solving this entire equation, we'll see this sort of formula. And this is a very good way to prove that the square root of x is greater than x. One, because it literally just shows it in the equation. And you can see here that if we just look at this part of the equation, it's already saying that x is less than the square root of x via the proving steps. So yeah, I don't really know what to highlight here because it's kind of just the entire thing. I'll just highlight the answer. So yeah, moving on to problem number 2. For how many 2-digit integers is n is the square root of 6n in an integer? So I've done a problem similar to this in the past, except this time there are a couple more conditions. But if the n is meant to multiply with 6 and create a perfect square, there is, prime factorization first of all. So 6 can be split into 2 times 3. If we're trying to make a perfect square, there has to be a 2 set or a 4 set or an even number power of the same thing to be able to take it out of the radicial. So n will fulfill that part for 6. It'll fix the parts that are not yet square root to make it able to be taken out. But it's also asking how many 2-digit integers for how many, so there's going to be multiple. And the first thought you might get is probably just 6, because 6, 36, you know? It's asking for 2 digits, so that makes our situation a tiny little bit more complicated. But we know that, but the 6 idea is very good, because this means that we're going to have to take in another 6 to make this, in the most basic necessity, a perfect square. So this is like just the basics of n. But we can build on those basics to create 2-digit integers instead. But if we're trying to build on, there is a very specific thing we have to match up to, and that is the number that we're adding on to the 6 has to be a perfect square, so we can take it out altogether. So this means if I list out all these perfect squares here, I'll just list out to 5, I guess. We can take any of these perfect squares, and any above it as well, as long as it fits the conditions, to take it into the equation and make it so that it becomes a 2-digit integer, and you can take it out of the radicial. So, using that idea, if we bring the square root of 1, no, not the square root, the square of 1 is just 1. So that doesn't work because that does not make it a 2-digit. But 2. So 2 to the 2 square is 4. So if we bring that into the equation, 6 times 4, which is 24, so 2 to the power of 2 does work in this case. And that is one possible solution we could get. And it's asking how many. So we can keep adding on. So 3 to the power of 2 is 9, so 2 times 3 is 6 times 9. Check. 4 and to the power of 2, which is 16. If we bring that into the equation, 16 times 6, that is also less than 100, which is our first 3-digit integer. But however, 5 to the power of 2, 25 times 6 is over 100, which means that it's going to be a 3-digit integer, so that does not work. So in this case, you can see anything above 5 to the power of 2 isn't going to work either because that's going to be way too big. So we can see here we have 3 solutions, 2 to the power of 2, 3 to the power of 2, and 4 to the power of 2. So this means that there are 3 cases. So that is how many 2-digit integers. N is 6n, square root, and integer. There are 3. So yeah, that's the end of this video. I hope you guys enjoyed, and I hope you guys learned something new, and I will see you all on the next one. Bye-bye!